Hello, Algebra 1 crew. Hopefully your day is going well so far. Today, what I would like to do is I'd like to continue our discussion of solving absolute value equations, specifically focusing more on problems where you have operations outside of the absolute value symbol that you have to do before you tackle those operations inside of the absolute value symbol after splitting off your problem into two pieces. But before we get into that, I first want to talk a little bit more about literal equations and just show you one more example of a literal equation. We'll have tomorrow and Friday to practice this more as well, but I know probably doing one problem every day will help try to iron out some of those misconceptions. All right, so starting with a problem like this, we have AB minus CD all over E equals F. We're given that equation, and we're told to solve for B. What that means is my goal is to get B by itself, right? My goal is I want B equals a bunch of stuff. Okay, what that stuff is going to be, we'll find out, but my goal is to say B equals. Right now I have F equals. I don't want that. I want B equals. So you identify your variable B right here, and you kind of know that in order to get B by itself, we'll eventually have to get rid of this A that's being multiplied to the B. But before we can tackle that, we need to first get rid of this minus CD that's stuck onto the end of AB. But before we can even get rid of that, I need to take care of this whole big division by E so I can even access this numerator in the first place. Right now, that numerator is trapped all over this value of E. So in order to get rid of this big division by E, I'm going to first multiply by E. Because taking some quantity, dividing by E, multiplying by E, just gets you back where you started. Of course, we can't change one side of the equation without changing the other. We need to preserve equality, so we multiply the other side by E as well. That gets me to AB minus CD is equal to F times E. I'm just going to write it as FE, right? We don't stick them together to make some new hybrid letter. It's just F times E, whatever that would happen to be. All right? Now, in order to get B alone, I need to first get rid of this minus CD that's stuck onto the same side of the equal sign. We do that by adding CD, which of course I have to do this side as well. That gives me A times B is equal to FE plus CD. We can't stick those together. They're completely separate things, so we just leave them as completely separate things. Last but not least, I have A times B. I need to undo that multiplication of A times B. That's done by dividing by A on both sides. That's going to cancel out the multiplication here, leaving us with just B equals FE plus CD all over A. And we've now accomplished our goal of getting B by itself through algebraic steps, and we're able to put a box around that as our final answer. Again, the goal of something like this is to get whatever this variable is alone. If it says solve for B, we want to get B equals. Now, how do I do that? I need to eliminate one by one all of the other terms on the same side of the equal sign as B. All right. The advantage of doing this, just to explain that again, is if we knew the values of all of these other things, say we had a word problem or an application, then we could just plug them all in and get our answer without having to do any algebraic steps after the fact. If we didn't, and I knew A, C, D, E, and F and not B, then I'd have to plug in and then do algebra after that. So it saves a little bit of time if you're able to manipulate the equation ahead of time. All right. So hopefully that cleared that up a little bit. Again, we will be practicing the next 2 days, but hopefully between seeing a couple more examples yesterday and today, it's starting to make a little bit more sense. All right, let's delve back into the absolute value stuff. Nice little review of what we did last time. Problem like this, ready? I have the absolute value of negative 10 minus 4x is equal to 34. Okay? Again, the absolute value refers to some quantities, a value's distance from 0, right? So we know that the absolute value of positive 34 is 34, and the absolute value of negative 34 would also be 34, because that negative 34 is also 34 units away from 0. So what we can do with something like this is you can recognize I have the absolute value of a quantity equals a number. I can say, well, hey, if I can get this inside part to equal positive 34, That would be great, because if this part on the inside equals 34, then the absolute value of 34 will be 34. But also you could realize, well, not only could it equal positive 34, but this part on the inside could be negative 34. And that would be okay too, because the absolute value of negative 34 would equal positive 34. So that's why our absolute value splits off into two parts. One to cover the positive case and one to cover the negative case. And now we're just left with two-step equations that we can solve. We do that by adding 10 to both sides. We should be pretty comfortable with this by now. We get negative 4x is equal to 44. That's 34 plus 10. Divide both sides by negative 4 to undo that multiplication. Gives us x equals negative 11 for our first solution. Second one, I'm going to do the same thing to solve. Add 10. I get negative 4x equals negative 24 this time. Divide both sides by negative 4, and our other solution here comes out to be x equals 6. Negative 24 divided by negative 4. Remember, negative divided by negative makes that positive. Okay? Hopefully that made sense. We also saw a couple other problems where we saw an operation on the outside of the absolute value, which we had to deal with before we could split apart. So consider a problem like this. 3 plus the absolute value of negative 7x is equal to 59. Before I can split this apart, I need to have the absolute value of a quantity equals a number. I don't have that right now. Right now I have 3 plus the absolute value of a quantity equals a number. So I need to isolate the absolute value part, or get the absolute value part by itself on its own side of the equal sign before I can do that splitting idea. So that's exactly what I'm going to do. I'm going to subtract 3 to move it over to the other side, because that's how we're going to get rid of a plus 3. Gives me the absolute value of negative 7x is equal to 59 minus 3, 56. And now I have the absolute value of some stuff equals 56 equals a number. We're going to split this off to say, well, negative 7x could equal positive 56. That would make me pretty happy. And negative 7x could also equal negative 56, because if it did, the absolute value of negative 6 would be positive 56, and that would satisfy me as well. So now I can go and solve my two one-step equations by dividing by negative 7. I'll get x equals negative 8 here. And if I divide by negative 7, I'd get x equals positive 8 here. And so those are our two solutions. All right. Another problem that we saw the other day was, what if I have a number multiplied on the outside, or divided? It would work the same way, but something like this. Negative 6 times the absolute value of 2x minus 9 equals negative 42. I like this problem a lot, because you may look at this problem and say, ooh, it's kind of a no solution thing going on, right? You remember from last time, if I have the absolute value equals a negative, that can never happen. But hold on, before we get to that, notice I have negative 6 times all that stuff. Before I can do my splitting and make that determination of whether or not there's a solution, I need to get rid of this multiplication by negative 6 to isolate the absolute value, get the absolute value stuff alone. And I can do that by dividing by negative 6, which I need to do on the other side as well to preserve equality. That gives me the absolute value of 2x minus 9 is equal to negative 42 divided by negative 6, positive 7. And now you might be like, oh, okay, can breathe a sigh of relief. Okay, that's not bad. Absolute value equals positive. I'm in my happy place. I can go from there. All right, hopefully that makes sense as to how we got there. Now I can split. I have the absolute value equals a quantity. I can say, well, let's try to make 2x minus 9 equal to 7. Or we can try to make 2x minus 9 equal to negative 7. Either way would be very good, because the absolute value of both of these is 7. And these are just two-step equations that I can solve. We add 9 to both sides. You get 2x equals 7 plus 9, which is 16. Divide by 2. And our first answer comes out to be x equals 8. Over here, I would do the same thing, where we would add 9. I get 2x is equal to negative 7 plus 9, or 2x equals 2. Divide by 2, and 2 divided by 2 is 1. Our second answer, x equals 1. right? Cool. So that's stuff that we've all talked about yesterday, but I did want to show you another example of each of those just to sort of hammer those points home. All right. Now, let's step it up a notch. Let's take a look at some new stuff. Ready? Oh boy, it's going to be fun. How about this? If I had negative 10 times the absolute value of negative 9 plus 3x plus 7 is equal to negative 23. All right. Notice we have two operations on the outside. We have negative 10 times this absolute value and then plus 7. All right. And what I want to compare this to is I want to compare this to solving an equation like this. Right? Forget about the absolute value for a moment. Suppose I just had that two-step equation of negative 10x plus 7 equals negative 23. How would I solve that? Well, what I would do is realize I want to get the x by itself. So I'm going to subtract 7 over to the other side, giving me negative 10x is equal to negative 23 minus 7, negative 30. And dividing both sides by negative 10, that is how I would get x alone. In this case, x would equal 3. Okay? So we're going to follow those same steps over here with this absolute value. Think of if this were just x. Right? We're trying to get that alone, just like in a two-step equation, how we try to get a variable alone, right? So we can go through that same process of isolating the absolute value. I would subtract the 7 first. We got negative 10 times this absolute value of negative 9 plus 3x is equal to negative 30. Just like, see this, what's going on here? The process mirroring itself. Just as if this were a variable, we're trying to get it alone. So now I'm going to divide by negative 10. That gives me the absolute value of negative 9 plus 3x is equal to 3. All right. And now I have the absolute value of a quantity equals a number, so I can split apart and say, well, hey, if I can make that middle piece, negative 9 plus 3x equal to positive 3, I'd be happy. Or if I can make it to negative 9 plus 3x equals negative 3, that'd be fine too. Right? That'd be fine too, because the absolute value of 3 is 3, and the absolute value of negative 3 is also 3. I'd now solve this like I would a two-step equation, just like up here. We can add 9 to isolate that variable. We get 3x equals 3 plus 9 is 12. Divide both sides by 3 gives us x equals 4. Okay. Over on this side of the equation, add 9. We get 3x is equal to 6. Divide both sides by 3, we get x equals 2. So our two solutions in this equation are 4 and 2. All right. Let's take a look at another one. We got 3 more to go. Ready? How about 9 minus 7 times the absolute value of negative 8 minus 2x? Okay? And we're going to say that that's equal to negative 75. This is a super common student mistake that I want to point out. It's just like if I had a problem like this, right, to compare it to that two-step equation. A lot of students would be tempted to say, ooh, 9 minus 7 is 2. And so can I just write that as 2x? No, no, no. Very, very bad. Please do not do that. This negative 7 is attached to the x. Same deal over here. This negative 7 is being multiplied to the absolute value of this stuff. Okay, it doesn't just pull apart and pair up with the 9 because it feels like it. This negative 7 is attached to this. All right, so just like I would over here, to isolate the variable, I would subtract 9 from both sides, giving me negative 7x equals negative 84. Divide both sides by negative 7. And I would get x is equal to 12. Okay? Notice I'm going to do the same simplification steps over here in order to get that absolute value by itself. I'm going to subtract 9 from both sides. Gives us negative 7 is equal to negative 8 minus 2x is equal to negative 84. See how similar of a process it is? You're really going through all those same simplification steps. Divide both sides by negative 7. We're going to get the absolute value of negative 8 minus 2x is equal to negative 84 divided by negative 7, positive 12. Now, just like we did over here, kind of cool, like it's really the same process. I love seeing them side by side. You can probably tell I'm getting all giddy and excited because now we can split this up just like we did all our previous problems and say let's try to make negative 8 minus 2x equal to positive 12. And let's also try to make negative 8 minus 2x equal to negative 12 because either way, the absolute value of that would be 12. Solving our two-step equations now, we would do adding 8, giving me negative 2x is equal to 20, 12 plus 8, and then divide by negative 2 to undo that multiplication, gives us x is equal to negative 10 for that first one. I almost said positive 10, I almost made a little mistake, right? Remember, positive divided by negative is a negative. And then over here, I would add 8, gives us negative 2x is equal to negative 4. And lastly, divide both sides by negative 2. Negative divided by negative, I won't mess it up this time, that's a positive. Negative 4 divided by negative 2 is positive 2. All right, so hopefully that makes sense. Like I said, I have 2 more that I want to go through with you. I won't do this side by side for the rest of them though, but because it obviously takes longer. But I think it's great to see that we're really just doing the same algebraic steps as if this were a variable, right? Just as if this were a single x. We would try to get it alone, just like you see over here. It just so happens to be this absolute value of a big quantity, but you treat it the same way you treat a variable in the sense that you're trying to isolate it. All right, let's take a look at 2 more examples. I need to get myself a fresh sheet of paper, and let's give it a shot. All right, you ready? How about 7 times the absolute value of 3 minus 3x minus 10 is equal to negative 73. Okay, let's try that one. Again, just like if this were a 2-step equation, I would isolate this by adding first, right? Because just like if you had 7x minus 10, you would get rid of the minus 10 first. Brings us down to 7 times the absolute value of 3 minus 3x is equal to negative 63, right? Negative 73 plus 10. Now I can divide by 7. Brings us to the absolute value of 3 minus 3x is equal to negative 63 divided by 7, negative 9. And then, is what I say to that. And then, Why am I saying and then, Because I have the absolute value of a quantity is equal to a negative number. I don't like that. That's super bad because we can't take the absolute value of anything and get anything but a positive number or 0. There's no way I can get a negative number, right? So when I recognize I have the absolute value of a quantity equals a negative number, I can jump and say this would have no solution. And it would have no solution because the absolute value of any quantity cannot equal a negative value. So even though we didn't see that since yesterday, you still have to keep a lookout for when that situation occurs. All right? But let me do one more now, just to end. This one does work out, I promise, okay? But I did want to showcase a no solution just so you see it, that it's a thing that can happen in the real world of math. Ready? Let's do, this is a tricky one, 4 plus the absolute value of negative x plus 10, all divided by 2, is equal to 11. All right? So we have 4 plus the absolute value of negative x plus 10, all divided by 2 equals 11. Now, before I can tackle this big fraction, right now there's this 4 plus sitting out in front of it, right? So before I can even get to this, we need to get rid of this single term of a 4 over here. Again, think if it were 4 plus x over 2, we'd need to get rid of the 4 before I can deal with the x over 2. So I do that, and it brings me down to the absolute value of negative x plus 10, all over 2, is equal to 11 minus 4, which is 7. Now I can get rid of this big division by 2 by multiplying by 2 on both sides, bringing me to the absolute value of negative x plus 10 is equal to 7 times 2, 14. And now we can breathe a sigh of relief because, oh, I like that. We have absolute value of a quantity equals a number, a positive number, not a negative one like that one, right? So now I can say, well, let's try to get negative x plus 10, or the opposite of x plus 10, to equal positive 14. We could also try to get the opposite of x plus 10 to equal negative 14. And let's solve. Subtract 10 from both sides. Gives us the opposite of x is equal to 14 minus 10, or 4. And then we'll just divide by negative 1, because remember, the opposite of x is secretly negative 1 times x. I guess it's not a big secret anymore, but negative 1 times x. And I get that positive x equals negative 4. That's one of my answers. We find the other one by subtracting 10. Gives us negative x, or the opposite of x, equals negative 24. Let's divide by that hidden negative 1 times x that's really happening there. And it gives us x equals negative 24 divided by negative 1, positive 24. And so those would be my two solutions. All right. Hopefully no question on that. Just a little recap of what we did today. We first started with reviewing literal equations. Another great example of that. We talked about some absolute value problems that we encountered yesterday. Ones that were just straight absolute value of a quantity equals a number, where you split. One that had an operation on the outside, like 3 plus, and one that had a multiplying on the outside. We then went into problems with 2 operations on the outside. And we see that it's treated just like a variable would be, in the sense that you have to get it by itself, right? So first, we get this term by itself, by getting rid of any other additional term on the outside, and then I can undo that multiplication here, like in this example. And once you arrive at the absolute value of a quantity equals a number, positive number, then we can split into 2. All right, and that same pattern persisted here. And one thing that we encountered that we do always have to be on the lookout for is a no solution case, where even though we did our steps correctly, I ended with the absolute value of something equals a negative number. Bad stuff. We don't like that. So we say that's no solution. But here's another problem that works out just fine. All right. We'll stop there for today. We'll practice the next 2 days in class. Thank you so much for your attention and focus. I hope you had a great day. I hope you learned something. All right. I hope that made your day a little brighter and better. All right. I'll see you guys. Thank you so much. Take care.